Yeah, hello everyone and welcome back. So today we are going to discuss the another interview session on like JP Morgan. So recently one of my friend has attended one interview for JP Morgan for like Java backend developer profile. So he has shared me all the interview questions. So according to him the interview was very interactive. It was good and but it was quite lengthier. The interview goes almost 1 hour and 45 minutes. So there he told that they have uh, discuss about the projects, about the technologies he has added in his resume, like microservice, Java, and like Hibernate, and also like DB and all. So yeah, for this JP Morgan, I am like planning to like divide this interview sessions on two part. In the first part I will try to cover the questions which was shared by him related to microservice, Java and all, and in the second part I will try to cover all the other questions. Okay, so guys, if you want to get the alerts and all, so like I will ask you to subscribe my channel and also hit the like button. So guys, let's start our session for Java backend developer profile in like JP Morgan. So first question he encounter was like what are the key challenges he faced while developing the application using the microservice, because he has added in the project that he has used microservice and all. And in the first question was a little bit yeah, so like little bit explanation about the project and all, and then the interviewer jumped on that what are the key challenges he faced in microservice. Okay, so guys, let me explain this and you can explain in such a manner and you can add all these points so that interviewer will be very happy to listen that you have a very depth knowledge about this topic. And this microservice is very important. So it is important in terms that you know that what challenges you can face while developing any application using microservice, right? So first challenge can be service communication complexity, because yeah, so the problem can come that microservice must interact over a network. Usually it does using HTTPS, REST, gRPC, and other like messaging queue, right? So issue can be like so the issue can be like network latency, and issue can be like the protocol mismatch. Also the failure in downstream service can be cascaded, right? So these are some issues related to the network it can come, right? So the solutions, what is the solution? So use API gateway or the service meshes like istio and circuit breaker like history. And also you can implement like timeout, retries, and fallback mechanism if certain microservices are down. So there is one point that in service communication complexity you can face the challenges. So the second challenge you can face is like distributed data management. So in distributed data management the problem is that each microservice manages its own database. Okay, so issue can be like no share transactions, it means across the services, right? And the data consistency become eventual and not immediate, because we are talking about microservice, so it is actually in the distributed systems there can be n number of microservice. So the data consistency will be the problem, and the distribution of data management is also a very pain point in microservice. Okay, so like what is the solution for this? So solution wise you can use any event driven architecture, and also CQB, like command query responsibilities segregation. Okay, so these technologies you can use, or you can apply Saga pattern also. So Saga pattern is also a very good way to handle this distributed data management issue, right? So the third challenges you can face is like service discovery. So what is the problem in service discovery? Actually service so like service need to be scaled dynamically, so their location, IP ports may change. So it will be very like pain point, or it will be very issue to maintain all the information about the changing services location and all, right? So the issues can be like hard coding service URL does not work in dynamic environment. So basically it is not recommended to hard code the URL in dynamic environment related to the distributed system, because in those type of architecture the instance may get increase and ports and the URL get keep on changing, right? So what is the solution for this for the service discovery? So you can implement service discovery mechanism, like you can use like Netflix Eureka, and also you can use the Kubernetes DNS, okay, and also you can use like load balancer, and also like reverse proxies. So these are some solutions technologies which you can use and overcome the service discovery. So the other challenges you may faced is like configuration management, as this is a distributed system and there can be n number of microservices. So it will be very like pinpoint to configure and to manage the configurations of all microservices, because each service may have like multiple environments, like it can have dev, it can have test, it can have stage, it can have like production and all, and different configurations, right? So issues can be like configuration drift and the lack of centralized control. So you have to develop some like way where you can keep a centralized configurations, because let's say that if there is n number of microservices, so it is not a good approach to keep all the configuration like duplicated up, like configuration in each microservice. So in place of that you can create one like main or one common configuration management way by which you can manage all the configurations, okay? So as a solution, what you can do, you can use a centralized configuration servers, like it is provided by actually Spring Cloud Config or HashiCorp Vault. So HashiCorp Vault is also a very good example, okay? So yeah, so like externalize configurations and also you can version it. So by this way you can tackle this configuration management challenge. So the next challenge you can face is like regarding the monitoring and logging. So the problem you can face in monitoring and logging is that in distributed system or in distributed nature makes it hard to track the behavior across services, because there will be n number of services, right? It is very hard to check the logs and to monitor all the services and all. So the solution wise, like it is difficult in tracking request path, right? I mean that which microservice is connecting to which microservice. So this kind of communication and the mess will be so huge that it will be very difficult to understand the process and the flow of the microservices, right? And it will be very hard to correlate the logs also, right? So as a solution, what you can do, you can implement centralized logging. For example, we have elk stag or loki, or like we have one more that is called as a grafna, okay? So we have like grafna. So all these technologies you can use to centralize the log. And in distributed tracking tools also, like Zagger and like Jipkin, okay? And yeah, so there are some tools also you can use for distributing like tracking tool as a distributing tracking tool. And also you can integrate a matrix with also like Grafana and all, right? So these are way by which you can overcome this monitoring and logging. But this is very important point, like monitoring and logging is there in every like application. So these things you have to keep in mind. So the next challenge you can face is like in the deployment and DevOps complexity. So problem you can face is like managing the multiple deployable unit, as it is like distributed system and number of microservice. Again, the challenge will come to deploy to the multiple deployable units. So issue can be like to coordinate during the release. It will be hard to coordinate during the release time. Rollbacks are complex because there may be chance that for certain service you may have to roll back. So it will be very hard to maintain all these things. So as a solution you can go with actually containerization like Docker, or like orchestration tools like Kubernetes. And you can implement CI/CD pipeline with the feature flag and like deployments. right? Yeah, so this can be one approach to overcome this deployment and DevOps complexity and all. So the next challenge you can face with the security, and security is a very main expect in terms of microservices, right? So more exposed services increase the attack surface, right? So issue can be like secure communication, authentication and authorization per service should be there. So these are some like pain points. So as a solution, you can use like auth 2, you can use JWT token, you can use mutual like TLS, and also you can implement API gateway security like policies. And also there is one more like zero trust architecture. So these kind of solutions you can opt for. And also one more thing, you can, for security purpose, you can implement this to the API gateway. So in the microservice architecture, we have a API gateway where you can implement all this. I mean the security features like auth to JW token and mutual TLS, so that it will try to cover this and try to provide the security to the all microservices, right? Because we know that API gateway is the main entry point for your microservice and all, right? Yeah, so the next challenge you can face is team and code base management. So this is very important because services are built and maintained by development team or different team members, right? So issue can be code duplication, it can be inconsistency in standard, so that every developer has to follow some standard and all, and the code duplicate and the duplication work can be go. It will be hard to maintain the team and code base management. So as a solution, what you can do, you can enforce shared libraries, and you can enforce coding standards, and something like DDD, that is a domain driven like design, some kind of this architecture you can use. And also you can apply for micro front end or full stack isolation, so that it will be very easy to maintain the code base and the team, right? So the another challenge you can face on testing complexity, because see, testing is very important, and here we are talking about not one service but a number of services for as a whole product. So testing comes a very important part before delivering the product to the production, right? So unit testing is easier, but integration testing is hard in this, because unit testing we do for particular service, so it can be easy. But when we go with the integration testing, where we have to do the testing from end to end, then here we may face some challenges. So issues like ensuring stability in the integration and end to end testing can be the pain point. But how to resolve this? As far as a solution, I will suggest you can use test containers, contract testing, okay, like you can use the mock services, and wherever it is required you can mock it. And also you can do some automation to the test in CI pipelines. So these are some like solution which you can use while like resolving the testing complexity. The next can be the versioning and the backward like compatibility, because this is again one more challenge you can face, because updating one service might break another, right? So issue can be like client may depend on the older versions and all. Okay, so solution wise, what you can do, you can use API versioning like strategy, or you can ensure that backward compatibility with contract test. So of course you have to go with the versioning policies and all, so that it will easy for you to maintain, and you can revert it, or it should your code should I mean support the older versions also, because might be in some case some of the customers may use the older version only, and some may try to use some feature from the new versions. So this type of like solution you have to provide. The next challenge you may face is a fault tolerance and the resilience. This is again very important, because one service failure can bring down the whole application or whole system. So issue can be like no isolation of failure zones. So what you can do as a solution, you can use the bulkheads, you can use the circuit breaker, you can use the fallback mechanism, you can go with the retry mechanism and all. So there are n number of way where you can eliminate this fault tolerance and all, and design service to be stateless and resilience. So this is one more solution for fault tolerance and like resilience. And again, the very important is cost and overhead because of course the means it totally depend on the infrastructure and the operational overhead increase, because once you go, or like if you choose the microservice, then here the cost will get increased, right? So here we need the more DevOps team, we need more tools, we need more services, etc. Right? So of course the cost and all will be the overhead, right? So solution adopt microservice only when needed, okay, and try to evaluate the team capability, budget, and the project scale. So then only you have to go with the microservice. Yeah, so these are the some challenges I have discussed with you, and also the solution that what you can opt for. And if you pitch in the interview in this manner, I mean, first you showcase the challenges in microservice, and then you also provide the solution with it, then I believe interviewer will be very happy to know that you have a very much depth understanding about this topic, right? Okay, so let's move ahead. So the next question he got was, what is API gateway and what is the role of API gateway? So this is very important question. I have seen in many interviews. I mean, in almost every interview, this question will be there, because API gateway is a, one of the main component when you are designing any microservice architecture application, right? So an API gateway is a server side component that act as a single entry point into a system, like made up of multiple microservice. As I told you, that it is the single entry point. First, API gateway will be get requested, and then API gateway will try to transfer the request coming from the customer to the other microservice or the other component in a whole system, right? So basically it abstract the internal architecture, centralize cross-cutting concerns like authentication, logging, rate limiting, and enables a smoother client to service communication. So in API gateway, you can add authentication, logging, and the rate limiting. All these features you can add it in a API gateway so that it will be the centralized way, because you are using into because you have to deal this with the every microservice. So it is a best idea to put it into a centralized or in a common place. So API gateway is the best place to add all these features to your system, right? Okay, so now yeah, so like let me explain you one like real example regarding an API gateway. So imagine that your microservice architecture is like a city, okay, with a different buildings as a each services. Let's say you have a four buildings or a four tower in one society, okay. Then each building or each tower is like a service, okay, is like a microservice. Now, like instead of requiring a visitor, let's say some like visitor came to visit, so instead of knocking every each door, or I mean each tower, it is good that in the fronts, yeah, so like it is good that there will be a front desk basically. So that is called an API gateway that handles all the incoming requests of the client or the customer, checks the credentials and route them to the proper building or tower, okay. So like that, in a society we have the guard room in the main gate, right, where if any guest comes, then first he tells that which tower he has to go, and which yeah, and like which tower, which like flat number, and the person name, right? And then and then the guard person do call to the flat member and checks that whether some your guest with that this name has come to visit you. So is it like good to allow him to go inside, right? Yeah, so this is actually the authentication and all. And they and and they also take the entry, so that is also logging and all, right? Yeah, so all these features can be related to the API gateway. So here in the society we have a main gate, in the main gate we have a guard room. So you can consider in the layman language that a guard room is a API gateway. From the guard room, your customer or the guest will be redirect, and they will show the direction that this way you have to go or that way you have to go, okay. Yeah, so like this you can consider a API gateway. Yeah, so like I yeah, so like I hope you got the idea about API gateway. Now the core roles and responsibility, this is important. So core role and responsibility of the API gateway is first is like request routing. So what it does, actually it accept the request from client and route them to a appropriate backend service or to a particular microservice. So why it is important? Because client do not need to know the internal URL or how many services exist, right? So that's why we are using API gateway, and this is very important point. Why we need API gateway for request routing? Because we want that client should not know the internal URL where we are transferring or where we are calling to a particular microservices. Okay, so he does not need to know the internal services that where it exists. So that's why we have one layer in the starting, that is an API gateway, okay, which will hide all your internal system, right? So example that client call get slash order slash 123. So this will try to get the order with ID 123. In this, the gateway route it to the order service, because let's say we have order service of microservice, then it will route to the order service, and then it will try to call the endpoint of that order service and try to fetch the data. So this is done by API gateway in the request routing. Now, okay, so now the second point, the core role is like aggregation of services like backend for front end. So that is a BFF pattern, right? So it combines a multiple services call into one response, because there may be chance that some okay, so the client is looking for the response that must be calling like multiple microservices, and the combination of the services we have to return it. So here the aggregation, or we can say that aggregator like design pattern comes into picture, where the response from the multiple microservices combine, and then the final response is returned back to the client. Okay, so why this is important? Because it reduces the chattiness between the client and the server, especially important for the mobile apps. Okay, for example, instead of client making three API call to the user order or to the product services or to the any other services, the API gateway makes those internal calls and then send only one consolidated response. Because see, a client need only one response. So client does not need to call the three APIs to get all the response, because here we are talking about microservices. All the individual all the individual business unit are divided into different microservice. So this should be the internal work, right? It should be handled by API gateway itself. So client has to call the request which he had to get, and the API gateway will internally take care. API gateway will internally call the other three means services. It will take the response from that three services and then consolidate it and then return back to the client. Okay, so that's why this is very important. The third role is for authentication and authorization, as I discussed earlier, because we need to verify the client identity and permission before forwarding the request, whether the client has the proper uh, permission and the authentication for accessing the system or not. So that need to be checked. Okay, and why it is important? Because see, offload security logic from service and enforce a centralized mechanism. So it is a very good idea to make this security approach in a centralized manner, so that this authentication authorization should not be implemented in each and every microservice. Rather than you can put it into a centralized or common place, from where these checks will be done, and then only the request will be allowed to go inside the system, right? For example, you can say that API gateway checks JWT token and validate the roles before passing the request to a microservices. Okay, yeah, so I hope you got this. Now the fourth role is like rate limiting and the throttling. This is very important. Rate limiting is very important, because there may be chance that the hackers may yeah so, the, so like there is a DOS attack. Okay, so DOS attack is nothing but where the user or the hacker try to exhaust your system by putting so much request in a particular interval of time, so that your system will not able to means response all those requested, and it will fail, right? So to eliminate this, we have a rate limiting. Okay, so here, like, why it is yeah, so like what it does actually, so limit how many requests a client can make it in a given time. So basically rate limiting is nothing but it limits that there is a particular amount of request a client can do in a particular amount of time. So why it is important? Because it protects the backend service from abuse and ensure like fair uses, right? For example, a client may be limited to 1000 requests per hour, right? Yeah, so this kind of rate limiting we can put it so that it will help us or help the hacker, yeah, means yeah, so like it will help us to be get like free from the hacker that who try to exhaust your system, right? So the next role is like caching. So this is very important. Why does? Because it store the frequent API response to server repeated request faster, because there may be chance that sometimes a client is doing the same request again and again, again and again. So again it will go and directly hit the microservice, and then it will take the response, and there may be chance that again that microservice is interacting with DB to fetch the responses. So better there should be some caching technology, so we can add this in the API gateway, so that if there is a same kind of request is coming again and again, so that it can directly provide the response from that caching only, and it can reduce the load or the backend service, and also it can improve the performance. Okay, now the next role is like logging and monitoring. So logging and monitoring is like to collect the logs and to metrics for every request, right? So why it is important? Because it helps in debugging and performance monitoring and security auditing. Because debugging into a microservice is a very real and tidy job, and it is very important. I believe nowadays we are using n number of AI tools, but I believe the debugging can be only done by the developer, because it cannot be helped by, yeah, I mean that they can suggest you that what aspect you have to check or where you have to check or what you have to do, but for a debugging as a developer has to do. So there should be some centralized way where you can see the logs, and also you can monitor your services and all. So that's why this is very important. Like, for example, you can log the incoming request responses, also you can log the response time, error, and the user details. Okay, so you can log n number of things, and you can also monitor the health and all. Now the next core role is like SSL termination. So basically, it decrypt the HTTPS traffic at a gateway level before routing internally. Because for security purpose, SSL is very important, right? So it is better to add into a common place that is in the API gateway. Now the next is like request and response transformation, and also we have a CORS, that is a cross origin resource sharing. Okay, so that is also important. So request and response transformation, what it does, it modifies the header, request response format, and payload. So to adapt the internal service response to match client exception. So for example, you can transform the XML, JSON, or modify the date formats and all. So these are some core roles of API gateway. Yeah. So yeah. So like I hope you got the answer about this question. So final thought I can give, that without API gateway, client need to call multiple services directly. And also, as a security and policies must be duplicated in every service. And also, it increase the complexity and overhead on the client side logic. So to eliminate all those things, you can go with a API gateway, because in API gateway, it will be centralized control, your security will be centralized, your logging, your monitoring, you can add cache in a centralized manner, right? So code will be cleaner, and also it will be like maintainable, right? So this is very important. Okay, yeah, so like I hope you got the idea about this API gateway in a very depth manner. And and like I will suggest you to explain this question in this manner only, so that interviewer will know that you have a very depth knowledge about this topic. Okay, now let's move to the different topic, that is, what is data consistency and how do you handle data consistency at distributed architecture. Actually, he got the question that whether you are checking that your data consistency is there, or if it is there, then how you are handling it. So this is a very important question he got. So actually, handling data consistency in a distributed microservice architecture is one of the most challenging aspect of designing and maintaining the microservices. Since each microservice typically has its own database and operate independently, and also it maintain the consistency, especially strong consistency, become very complex, right? So like data consistency ensures that the data remains accurate, correct, and synchronized across multiple services. So in microservice, due to distribution, achieve a strong consistency, like uh, like we can achieve a strong consistency in like monolithic system. It is very difficult to achieve a strong consistency of data in microservices. Okay. Okay, so like let's discuss about type of consistency. So there is a strong consistency, eventual consistency, and then casual. So strong is like all nodes see the same data at the same time, suitable for monolithic, hard in microservices. So if you are with a monolithic, then strong consistency is possible. Now the next is eventual. In this, after some time, all the nodes or data replication will become consistent, preferred in microservices. But actually, it takes some time to update to all the nodes, or to all the components. Okay, so yeah, so like it will be the good choice for microservices kind of architecture. The next is like casual. In this, ensure that related updates are seen in the same order. Okay, yeah. So mostly with the microservice, which we go with the eventual consistency, where we use the saga pattern and all. Okay, so yeah, so let's see. Okay, so challenges in microservices regarding the data consistency. First is like distributed database, because in every microservices can connect with the different microservices, so it is very hard to uh, update the data in every microservices. So data consistency will be challenges in distributed database. Again, the network partitions, networks, because different networks, so there will be maze of networks. So because which microservice is communicating with which microservice, it means become a very mess kind of thing. So network partition is there. Independent failure of service, there may be chance that one service is failing, so how you will update that service, right? So it is actually a big challenge. Again, the concurrency and rest conditions may come. Again, the transactional boundaries across services. So these are some challenges you can face in microservice while attempting for the data consistency. Now let's discuss the technique to handle the data consistency in microservice. So you can keep it as like database per service. So like each microservice on its own database, so this avoid tight coupling between introduced data consistency challenges. Again, you can go with the second point as a saga pattern. So saga pattern is a very good example and the very useful technique to handle the data consistency in microservices. So what is saga pattern? Actually, in saga, a sequence of local transactions where each step has a compensating transactions to undo it in case of failure. So actually here we use a local transaction and we can undo a particular transaction, and then we can revert with the reverse event that this transaction had got failed, so we can roll back it easily. Okay, so yeah, again is there is a like again there is a event driven architecture. So like service communicate using a synchronization event, like that is Kafka, RabbitMQ. So in event driven architecture you can use Kafka, RabbitMQ, and there are n number of events driven, where it generate a event and then it tells to the another microservice communicating to it that the that this communication has get succeed, so that they can do the another communication to the different microservice, right? The another point is like idem potency. This is also very important. It ensures that repeated processing of a same message event does not cause duplicate or inconsistency, because there may be chance that if the one microservice call or the request get fail, then there may be chance that a multiple request has to be done. So idempotency to be implemented in data, in microservice for data consistency is very important, because it should not duplicate the data process, and it should not cause a duplication problem, right? So in this case you can use a unique request id token or any like versioning. Okay, the next technique is to change data capture, that is a cdc. So it tracks the changes in services database and emit a event accordingly. Okay, so it keep other services updated in near real time. Okay, now the another technique is like versioned and immutable events. So events should be immutable. It means the event should not get changed or it should not get modified. It should be immutable, so that the correct data consistency request will be done. Okay, and you can use the versioning for backend compatibility. So there may be chance that a rollback have to be done, because if any a microservice fails with another service and all. Yeah, so these are some technique where you can use, right? And also for data consistency there is a cap concept. Okay, cap is like consistency, like a cap means cap. C means consistency, a means like availability, and P means like partition. But for any like product or for any architecture, microservice architecture, at a one time you can only opt for two like trade off. Like I mean, you can opt for only C and A, or A or P, or P or C. I mean, you can opt for like consistency availability, or like availability partition, or like partition or consistency. So at a single point of time you cannot have all these three, right? Only you can choose two. Yeah, so if you choose two, then that system will be called as a very good system, and in terms of the data consistency, right? Okay, so let's go ahead and let's see the another question he got, like what happens if a microservice fails. Actually, what happens if microservice in a chain fail, and how to prevent this chain failure. Okay, yeah. So what is like cascading failure? So you need to understand that what is cascading failure in this. Okay, so see, if a microservice in a chain fail, it means that it can break the entire request flow, especially if the downstream services depend on the failed service response. Okay, then it can fail your whole system. So this can cause a cascading failure, because one service is down, so it may fail the other services to go slow, or also it can make the services overload or down. So where one failure leads to a chain of reaction across all the multiple microservices, which can bring down the whole system, or like significantly it can affect the performance and the availability of your system. So this is like cascading failure. Cascading means if there is a one failure, then it can may bring the failure to the other services also, right? So this is cascading failure. Okay, so a cascading failure in microservice occurs when a single microservice fails, or it goes slow, or it go down, or it get overloaded. So other services depending on it also get stuck or also get fail. So this failure ripples across the system. For example, there's a chain of services. So for example, so there is a client who is communicating with API gateway, and then API gateway is communicating with service A, and there is service B and service C. For example, if service C becomes slow or crashed, in this case service B will wait for service C, right? And here it will become blocked, because B will not get any response from C, because C is down. And again service A waits for service B. In this way the service A is also blocked, because service B is waiting, so service A has to also wait. So API gateway timeout or crashes will may come, because API gateway is not getting the response. So in this way the cascaded failure comes. So here you can see in the picture that only first time service C was down, but now it is not giving the response to the API gateway. It means the client receive a failure response, right? Yeah, so this is the best example to understand this. So now the question is that how to prevent this, okay? Because the question he has been asked that if there is a cascaded failure in microservice, then like what steps you can take to prevent it. So how to prevent cascaded failure? First, you can go with the timeouts. Timeout is the yeah, I mean timeout is a good option, but not the best option, because it depends on the scenario where where the timeout may can help you in the cascade failure, but it is not the best approach. Okay. So yeah, so like timeout sets explicit timeout on service call. It provide you the time period till which means it will set that whether you have to check for the means you have to give the request for this amount of time. If within this amount of time, if service is not responding, then you don't have to check for that service again, right? So it prevents service from waiting indefinitely, right? It returns fallback or error if timeout occur. So if there is a timeout, if within a timeout, if any service is not responding, then you can go with the fallback mechanism. You can use a alternative approach or alternative like business logic, right? So for timeout, you need to implement with the rest template, where you are creating a rest template, and then rest template has a method that is called a set read timeout, where we are putting 3000, it means 3 second, right? So in this way you can put a time set timeout time, that within this timeout, if anything is not getting a response, then you can add a fallback mechanism, or you can return back any response and all to the client. The second approach to prevent cascading failure is to circuit breaker. This is the best approach, I believe, because circuit breaker will prevent a service from calling a downstream services if it likely to fail. Because in our case, if we add a circuit breaker to service C, then to the service B, then the service B will not call to service C and all. Okay, so like that you can break the circuit or of communication between the failure service. So think of it like a fuse. It opens when failures are high and closes after recovery, right? So popular tool you can use is like Netflix Hitrix, which is now deprecated. And there is another tool like Resilience 4J and also Spring Cloud Circuit Breaker. This is very good options you can use as a tool to overcome this cascading failure by implementing the circuit breaker and all, right? Yeah. So in a circuit breaker, there are three states. First is closed, open, and half open. Closed means call flow normally. Open means short circuit calls to prevent the load, and half open test if the service has recovered. So basically, open means short circuit is there, so it will not pass the communication to the failure microservice, right? So for example, there is a service A, okay, service A, and there is a circuit breaker in between service B. If service B is down, the circuit opens and service A immediately return fallback. It means service A will not call the service B. In this way, it does not have to use the resources, and here the performance will become high. And also there is an option to use a fallback mechanism, I mean a alternative mechanism to return back the response, right? Yeah, so this is all about the second option, like circuit breaker pattern. Now the third is like fallback mechanism, okay, so which we discussed earlier, earlier, that it provide a default behavior, that what to do when if service get fails. And it also avoid hard failure by returning a cache data or placeholder value. See, for a client it is important that client is getting the response. If it is not a real time application, then of course you can return some cached data to the client in case if something fails with that particular service as a fallback mechanism. Okay, so in this case this can be very helpful. So how to implement this fallback mechanism? So see, so there is a get user method, right? So I have means added a screenshot of that so that it will help you to know that how you can implement it, right? There is a at the red circuit breaker annotation, where you are putting in this user service, and you are adding a fail break method. Fail break method is a property which you can pass the value as a method name. That's a fallback get user. So this is an alternate approach to use if this service get failed. Let's say that if get user is calling one user client dot get user method, and if this is fails, then circuit breaker will break, and then there will be fallback mechanism will be done, okay, or activated, and this will call fallback get user, and then this will pass. Okay, so here you can use any like your logic and all to return back as a fallback mechanism, right? So this is very important. Now let's discuss the fourth approach is like retries with exponential backoff. So retry failed called a few times, waiting longer each time. So prevent immediate retries, because there may be chance that again and again you are retrying the same thing, but again there is no point, right? So there is no point of trying or retrying for n number of time. So there can be some mechanism where you can put a limit or time, or any call number, or any time for which it will retry. So let's say here, so retry one will be done, and it will wait for some time, let's say 100 millisecond. If within this it doesn't get the response, then again it will retry second time, and then again it will wait for more longer time than the first one, that is 400 millisecond. In the third retry it will wait for 900 millisecond, and then it will give up. In this way the retry will not done like in the same time, but yeah, means it will provide some delay, so that if in within this time, if the service is back online, then we are good. Okay. Yeah, so next is let's discuss the next point is like bulkhead pattern is there, rate limiting pattern is there, asynchronous communication is there. So bulkhead pattern is like isolate service resources, it prevent one service failure from affecting others. Okay, so here we use a separate thread pool for database payment and notification. Okay, so rate limiting already we have discussed, I don't think we need to go into this. So there is a asynchronous communication also, where you can use the messaging queues, where you can use Kafka, RabbitMQ, AWS SQS to decouple services and all. So all these techniques are getting used in microservice technologies, right? Where your product is built with a microservice. Okay, so it ensures the service don't block when a downstream service is slow or down. Okay, now there is a monitoring and logging alerts, so you can use like observability tools to detect and recover quickly. Nowadays you can email it, like you can get the notification in your email that this service is down, so you can quickly check, and then you can opt for that yeah, so like you can opt for the necessary steps. So these are some like ways by which we can like opt for, right? Yeah, so basically for a conclusion, yeah, so I will say that to prevent cascading failure, use your should be design like deficiently with a circuit breaker, timeout and fallback. Okay, second point, you have to isolate the service using bulkhead and the thread pool. Fourth is like decouple the dependencies using messaging queue. And the fifth can be like monitoring and react. Okay, quickly you can react if you get any notification in your email, right, that this service is down. So these are some important points you can which you can opt for, or techniques which you can opt for to eliminate this cascading failure, right? Yeah, so like I hope you got the full idea about this question. Now the next question was, how could you design an API gateway that handles authentication, logging, rate limiting, and request transformation? Because as we discussed about API gateway earlier, so like designing API gateway that handles authentication, logging, rate limiting, and request transformation is essential in microservice, as we know, because an API gateway acts as a single entry point, as we discussed earlier, for a client, and it manages cross-cutting concerns and routing traffic to the backend services, right? So what is API gateway? Okay, so we have already discussed this, right? So okay, so let's move to the next is like it helps in centralize and simplify responsibility. So in which things it helps? It helps in authentication and authorization. It helps in rate limiting, logging, request response transformation, load balancing, caching, and all these things point I have discussed earlier, but I have added this so that you can make a note of this, because these are very important questions. Okay, so you can have a note of this with you, that whenever you have an interview or you are like doing a revision, then this will help you. Okay, Now, regarding authentication, like it verify if the request has a validate token or not. Logging will record the details. Red limit will control the number of requests coming to your service. Request transformation is like modifying the request response as needed, right? So now let's see, discuss the detail component design. So how you will design it. So for authentication and authorization, purpose is like to validate the token, identify the user make the request is a correct user or not. So you can go with like middleware or filter in the gateway, and you can decode and validate the JWT token. And also you can fetch the user roles permissions if needed and reject unauthorized request. So for example, you can use tool like Spring Cloud Gateway plus JWT. So here in this manner you need to implement it, where in the configuration class you have to implement this bean, that is Spring Security Filter Chain, where http.auth to resource server dot wt, it will validate the JWT token, and if is it's good, then it will return this http.build, right? So in this manner, by using a Spring Cloud Gateway plus JWT, you can implement authentication and authorization in your API gateway. So next is how to implement for logging. For this, you can go with a Spring Cloud Gateway global filter. Again, like logging is used for tracking API users and performance, help for debugging, enable auditing and compliances, right? So how you can implement it? You can log request path, method, timestamp, header, and user ID, and you can correlate logs using correlation ID, and you can push the logs to ELK, Loki, and CloudWatch. So example is Cloud Gateway Global Filter. So in this manner, you have to create a component. You have to implement within global filter interface, which has an method filter, which you have to override it. And then in the parameter, you have exchange server wave exchange object and gateway filter change. In this you can create a track id, uuid.random uid.toString, and then you can change the filter like chain dot filter. And then you have, yeah, and in this manner you can do the log.info, and then you can track with the track id. So this will give a trace id completely with every log you are adding it. So you can use Spring Cloud Gateway global filter to implement this logging in API gateway. Okay, so these questions will be answered with the experienced people, right? So these are the things which you should know while implementing uh, in your API gateway. So another is like rate limiting. We know the rate limiting, right? We have already discussed. So yeah, so like let's discuss the implementation part. So token bucket and leaking bucket algorithm. So you can use the Redis like rate limiter for this. For example, you can use Spring Cloud Gateway plus a Redis yeah, so like Redis like rate limiter. So in the YML file you can add like Redis rate limiter replensive rate is 10, and Redis rate limiter burst capacity is 20. So this is the burst capacity, means this will stop with the 20. Yeah, so yeah, so these are the limits which you can change as per your requirement. But yeah, in this way you have to do it. I mean, in this way, in this XML file you have to add using a Redis rate limiter. So you can implement this Redis rate limiter in your API gateway, something like this. So another is like request transformation. Again, to modify the incoming request to match the backend expectations, you can clean up or enrich the outgoing response for client. So use case, it can be like rename the fields, it can be user ID or UID. You can remove the sensitive information, you can add header. Okay, so for this you can use Spring Cloud Gateway. So for the file configuration, in this you can add request header x request id, and then rewrite path you can provide. Okay, and then in the code you can implement this filter which will come from global filter interface. And then you have a filter again method which you have to override it. And by this way you can do, yeah, so you can just pause and you can have a note and understand this point. Okay, so in this way you can implement in your API gateway for a request transformation. So these are the some ways where you can implement it, right? Okay, so let's go to the next topic, that how do you test a microservice that's depend on the that's depend on the many other microservices. So yeah, so this question was very important. Okay, let me see if we have any other question I missed. Okay, so how do you test a microservice that depend on the many other services? So this is very important. This is related to the testing of a microservice which is depending on the any other microservice. So this is actually the practical question. So this question is very important and tricky, because if any candidate or employee is not much having experience in microservice, then it is very hard for him to give the answer on this, because he should know the testing strategies regarding the microservice to opt for this, right? So the testing strategies can be like unit testing, which can be tested individual in the method level or function level for that particular microservice. And then there is a component testing. In this, test the service in isolation by doing a mock for that particular service. And then there is a integration testing, which we do by doing the communication between the different microservice, and then we test end to end whether with communication with this certain microservice, whether we are getting the correct result or not. And then fourth is like contract testing. In this, we validate the interaction expectations between the services, whether the contract is fine or not, whether we are getting the expected value when we are connecting or communicating with different service as a response or not. Okay, and then end to end testing. So this is very important, E to E, because it simulates the full request flow, where we do a full request flow from UI to backend to the database, and then we see that whether we are getting the fully response correct or not. Okay, so this is kind of very important. All right. Okay. Yeah. And also there was one more question which I have not added, was that I remember now that what is microservice and when to move from like monolithic to a microservice. Yeah. So yeah. So like almost I have means I mean that explain all these points earlier. So that's why I have not added this question. But still, yeah. But still, I will tell you that in you may get that what is microservice, means when to choose microservice or when to choose like monolithic. Okay. Okay, so okay, so like let me explain a little bit. So you should start with a monolithic, and then move to the microservice only when the code base become hard to manage, when the teams are stepping on each other toes. It means there may be chance that the team is getting so much big and all. Okay, and the third point, you can say that certain parts of the application need to scale independently. There may be chance that you need to scale a particular component or particular part in a very huge manner. So in this case, or in this scenario, you can opt for a microservice than the monolithic, right? And if there is a point or scenario where the deployment time becomes bottleneck, that again and again you have to deploy, so better go with the microservice, where you can deploy each service change like independently, right? And also yeah, so so the main point is like, don't start with a microservice unless you have a system that is too much complex to manage as a monolithic. Okay. Yeah, so this was the quotation was delivered by like Martin Fowler, and many, yeah, and like everyone should follow this, that don't start with a microservice unless you have a system that too complex to manage as a monolithic. Okay. Yeah. Yeah, so guys, with this I will stop this session, otherwise it will go to means yeah, so like it will go like too longer. So better I will create a second part in which I will try to explain the other questions regarding the other technologies what he faced. Okay, so thank you and have a nice day, and please share this lecture And please like subscribe and hit a like button so that when I will create a second part, then you will get a notification. Thank you.